Hi, eighth grade. This is lesson 4 of module 6. So let's get started. The build understanding is what we're going to do together, but I encourage you to go back and look at the Spark Your Learning. It will give you some review from the last lesson, and it'll kind of get you prepared for what they're talking about in this lesson. So I encourage you to do that if you haven't already. So let's read through the build understanding, and then I'll have you pause and we'll work on it together. The parking lot near the Scuba Company opens for the day at 6 a.m. Between 7 between 7 a.m. and 11 a.m., cars park at a constant rate of 50 per hour. At 10 a.m., 165 cars are parked in the lot. Write an equation that represents the situation in the form y equals mx plus b. So that's your actual assignment, but they're going to help you and take you step by step. So let's look at A. Write the ordered pair that represents 165 cars parked at 10 a.m. What does each coordinate of the point represent? B. What is the slope of the function? Use the slope and the point from part A to find the y-intercept and write the equation of the line. C. Can time be a fractional number? Why or why not? D. Can the number of cars be a fractional number? Explain your thinking there. Is the function discrete or continuous, and why? What are some restrictions for the possible values of y, and why? What are some restrictions for the possible values of x? What does the y-intercept of the function represent in this equation? So pause here and take some time and go through these the best you can, and then we'll look at them together. So let's look at A. A says, write the ordered pair that represents 165 cars parked at 10 a.m. What does each coordinate of the point represent? So I drew this little graph down here to kind of help us look at that. So they tell us that at 10 a.m., 165 cars are parked in the lot. So they say that they open or they start at 7. So what I've done here is you can see that I have the hours 0, 1, 2, and 3, and then I've kind of written the times there to give you an idea of kind of what that means. So if we look at after 3 hours, so that would be at 10 a.m., there are 165 cars. So that's going to be about right here, and then we want to go up from the 3. So not exact, but about right there. After 3 hours, it's 3 and 165. So 3 hours, 165 cars. So that would be our point. 3 hours, 165 cars. So that's the point that they're asking for in A. B, what is the slope of the function? Use the slope and the point from part A to find the y-intercept and write the equation of the line. So remember from the last lesson, the slope is the constant rate of change. And they tell us that the constant rate of change in this is 50 cars per hour. So the slope equals 50, and we're trying to get it into this slope-intercept form, y equals mx plus b. So we're going to take what we know and use the point. We can substitute the 165 for y, because that's our y coordinate in this particular case. We know the slope is 50, and we know that x is 3. And then we're trying to find b to be able to write that equation. So if we multiply, we have 165 equals 150 plus b. And then I can subtract 150 from both sides of the equation, of the equal sign, and I end up with, this cancels, so I end up with 15 equals b. And so now I can do this, I can substitute what I know. So I can say y equals m, which is 50, the slope, times x plus 15. So that's my slope-intercept form equation. And that would help you if you needed to find a point further on. Like let's say you want to know at 5 o'clock how many cars would be in the lot or whatever. If it keeps going, they say 7 to 11. But let's say I wanted to know at 11 a.m. I could switch the x for 4, and then I'd have the answer to that question. C, can time be a fractional number? So with this, what you want to do is you want to think about whether or not you can measure something in fractional units. And I can measure time in fractional units. I can say it's a quarter past the hour, 1/5 past the hour. And so, yes, you can measure time, can be measured in fractional units. And then can the number of cars be a fractional number? I doubt you would see a half a car or a quarter of a car driving into the lot. So you would say no, cars cannot be measured. Or you could say they would only be measured in whole units. So at least for this problem, you wouldn't, if you were talking about a wrecking yard or something, you might have half a car. But in this case, no, it's not can't be a fractional number. So E, is this function discrete or continuous? So this is where we would look at this vocabulary. So discrete and continuous. So this was actually from another lesson that you did a while back, but a continuous graph is made up of points, of connected points or curves, and a discrete graph is made up of unconnected points. And since cars can only be measured in whole units, this would be a discrete function because you would just draw points, you wouldn't draw a line. So So since cars are measured in whole units. And then F, what are some restrictions for the possible values of Y? So remember, if you look at Y, it's the number of cars. We know that the y-intercept, the starting point is 15. There are 15 cars in the lot at 7 a.m. That it would have to be greater than 15. And it would have to be a positive number. You wouldn't have a negative number of cars. What are some restrictions for the possible values of X? Again, it would have to be a positive value. Or 0. H, what does the y-intercept of the function represent in this equation? And remember again, the y-intercept is your initial value, so that is the number of cars that were in the lot at 7 a.m. or at the beginning. Okay, so after previewing the video, I realized that I needed to add a couple things. So for A, I forgot to answer this question. And I think you probably know it, but 3 is the number of hours. And 165 is the number of cars. After 3 hours. So that's the other one that I realized I needed to change is F. I wrote greater than 15 and positive. It can also be equal to 15 because it tells us that the number of cars at 7 a.m. where we figured out was 15. So, I'm going to erase this. And excuse me, I'm going to use the symbol. Well, let's see. So it has to be greater than, I can write a little bit smaller, greater than or equal to 15, and a positive number. And they ask why. Well, you can't have a negative number or cars. And you know that there, from the work that you did, there are 15 cars in the lot at 7 a.m. So that's the initial starting point. That may not be right, but maybe right about here. So that's the lesson for today. And I'll see you in 6-5.